Hi guys, welcome again to lesson 3 of our series here of building a tube amplifier. And the next component I'm gonna show you is a capacitor. A capacitor is a passive component, just like a resistor in a way, passive component that has two terminals, and its main job is to store energy in an electric field. So it's like a container to contain the electric energy or charge. If you look at this diagram here, capacitor is made out of two conductor plates that are parallel to each other, and there is the terminal here, the wire. And in between the parallel plate is a dielectric or a non-conductor. It could be air or plastic or paper in oil or any other conductive material. And these conductor could be any conductive material. Usually they use aluminum foil, and in the very high-end capacitors in the audio field they use silver foil because it's a very good conductor. So this is the anatomy of a capacitor, and I'll show you how the capacitor works in a DC circuit. Okay, let us say we have a DC source here, plus minus, and this is our capacitor here, this is the same. This is a symbol for capacitor also, two parallel plates with two terminals. And if I connect these with a wire, then there will be an initial flow of current, but only up to here. The electrons will be attracted to this side but cannot go through because there is a separation between the plates. And what you will have here is a positive a charge that will be in the other side of the plate. So what will hold these two together, the negative and the positive, is an electric field. It will be holding the charge together. So once it is charged up, just like filling a glass of milk up, once it's charged up, I can then cut the circuit, and this charge will stay. In an ideal situation, this charge will stay forever. But in real situation, because there is some leakage resistance, the charge will start to leak and then dissipate and discharge. But let's talk about ideal situations first. This is a DC source. It can charge up a capacitor, and once the capacitor is charged up, it just stays charged even though you break the circuit. The only way to discharge this, one way to discharge it, is to connect the two together. So naturally the electrons will find its way back going to the positive side, and then that capacitor becomes discharged or emptied out. So just like a container, it gets filled up or charged and emptied out or discharged by this means, or shorting it out. Or if I place some kind of resistance here, it'll go through the resistor and it gets discharged also. And that's how a capacitor kind of works with a DC circuit. And we will talk about an AC signal so that you could understand how it works with an AC also. Here's the AC signal. Okay, now guys, I'm going to show you about the AC signal, because when we talk about capacitors, we introduce a new voltage source or a signal source We have been talking about DC signal for quite some time, and now I'm gonna show you what an AC signal looks like. And the simplest one that you can relate to is the AC main that you use in your house. You know, the AC voltage that you use in your house. And an AC signal has two components. It has the frequency connected to it, and it has a voltage value. It's either peak or root mean square RMS, which is which is a DC equivalent to the AC signal. So a 110 volt RMS, which is what we have in our mains, in our outlets, and it's running at 60 hertz. 60 times, it's having a frequency of 60 times a second, 60 hertz. It will look like this as a sine wave. It's a nice sine wave AC signal, and you could see the peak value of this 110 volt is 155 volts, 0.56. So it's a pretty, the peak voltage is pretty high. You will go from a plus down to 0, go to minus. AC means it goes from plus and then 0 to minus. And this is the power supply or the signal that will interact with the capacitor. So knowing these, I can then show you how the capacitor reacts to this type of signal, because the capacitor only does one thing with the DC signal. It just blocks it. It won't allow the DC signal or DC voltage current to pass through. Now you have an understanding of an AC signal. We will create an AC source here, and since the AC doesn't have any polarity, at one point this becomes positive, and then this negative. At the other point it becomes negative and positive. It's because the AC is a wave. If this is voltage plus and voltage minus, and this is time t, your AC is a wave. Okay, and there are two, as I mentioned a while ago, there are two components that we need to look at the AC. We have the voltage and the frequency. So these are the important components of an AC signal or AC source. And let us say our AC source is 1 kilohertz, 10 volts RMS, just as an example. And then you have a capacitor here. So what's going to happen here in slow motion with the first half of the wave, which is positive, so this is positive, that's negative, it will charge the capacitor. So the capacitor gets charged with the negative, the electrons here, and then the positive field right there. Then when the other half of the wave happens, this reverses. This becomes negative and that becomes positive. So therefore the electrons have a way to go here. It gets attracted to the charge, the positive charge here, and the electrons here goes back because there is a positive charge here. It gets attracted to the positive charge here. So it will feel like it has a flow of current, which actually there is a flow of current. So the capacitor will allow AC to go through itself. But if you change this into a DC source, it will just charge up one time and then it blocks the DC forever. So the capacitor becomes an AC pass-through. That's what we call AC pass-through. It allows the AC to go through it and blocks the DC. So those are the two very, very important characteristics of capacitor. It allows AC to go through it and blocks the DC. Now, we will talk about the capacitor reactance, because the capacitor has a certain type of reaction towards the AC signal. Okay guys, we'll talk about the reactance of capacitor, which is a very important parameter that the capacitor the capacitor has. The reactance, the symbol for reactance is an X and a C in the bottom here, a sub C. So it is capacitive reactance. A reactance of capacitor is basically similar to a resistance of a resistor. The resistor acts acts the same with AC and DC voltages or sources. But for the capacitor, as we have talked about, it blocks the DC. So once the DC source is placed on a capacitor, it just fills it up, and once the capacitor is filled up, it doesn't do anything. It just blocks the DC. DC won't go through it. So it just charges up the capacitor, and that's it. But it's a different story with AC. We understand it based on the equation that is connected to the capacitor. Reactance, remember, is just like a resistance. It's also in ohms. So this is the basic equation: 2 pi f c, where f is frequency in hertz and c is capacitance in farads. Remember, the capacitor has a capacitance in farads, and so these are two important components with relationship with the reactance of a capacitor. So if you look at this equation here, the reactance is inversely proportional to the value of the capacitance and the value of the frequency. What are we talking about frequency? Frequency is the frequency of the AC source or AC signal. So it could be any frequency that is acting upon the capacitor. So if the frequency is high frequency, you remember it's inversely proportional. If this goes high, the reactance goes low. If the capacitance is high, the reactance goes low. Likewise, if the capacitance is low, the reactance goes high. Same with frequency. If that's high, if that's low, this will go high. So it's just an inverse proportional thing. So it's good to understand. You need to get the relationship first of the reactance of a capacitor, because remember, with the DC side of the capacitor, if you use the DC source, the capacitor does nothing. As seen by the source, it's an open circuit. But as seen by the AC source, it has a resistance. It has a reactance, kind of like a resistor. So the value of the reactance is also in ohms. Okay? So in that way, the capacitor now, we have now a device that we can block DC with it, and we could allow AC to go through. So if you have a AC source connected to a DC source, and you have a capacitor right here, this AC will go through, and AC is like this. one half of the cycle it goes one way, and the other half of the cycle it goes the other way. So it allows the AC to go through, but the DC will just get stuck in one side. It won't let the DC go through. So that is a very, very important characteristic of a capacitor that we can use, and it's used to build our circuit, because you have two different in our amplifier. You've got several circuits together, and you would like to block the DC source and only allow the AC signal, which is the sound or the voice, the signal that goes from one circuit to the next. So this is a very, very important component of a capacitor. This would conclude our lesson for capacitors. There are more things about the capacitors you can explore, but this is enough to give us an idea on when we design our circuit for the audio amplifier. Just remember, it blocks DC, allows AC to go through, and it's also like a bucket of water. It charges, it fills up with charge, and it can also discharge by shorting the capacitor or giving it a path, a circuit path to discharge. Okay, what we have here is the capacitor connected in series and parallel. Like resistors, you can connect capacitors in series or connect them in parallel. And when we're designing our tube amplifier, sometimes we may need to connect them in series or parallel if we don't have the right value. So to get the total capacitance, if the capacitor is in series, it is kind of like the inverse of a resistor. In parallel. This is the equation here. 1 over total capacitance is equal to the reciprocal of 1 over is equal to 1 over C1 plus 1 over C2, and so on and so forth, and C3 here. So basically, it's kind of similar to it's kind of opposite to the resistor in parallel. It's kind of similar in that way. Likewise, a capacitor in parallel is all additive. So C1 plus C2 plus C3 and so on and so forth. Similar to our resistor in series. So these are just the nice to know information in case we need to we don't have the right capacitance when we're designing stuff, and in your capacitor bin or anything like that, and you need a certain value. You could then play around with what value you have and create and get the right capacitance you need for your circuit. So this is very important when you're doing that kind of practice. So this is all we're going to talk about for capacitor in series and parallel. There are lots of other things about this, but this is what we need to know kind of for building our vacuum tube amplifier. Hi guys, this is an electrolytic capacitor. I'm going to show you the different kinds of capacitors I have, but there are many more out there. Common type of capacitor that we can see is what we call an electrolytic capacitor. It is tubular in form. You have the radial, the axial type of capacitor where you get the leads sticking out in both ends. And one thing particular about the electrolytic capacitor, it has a polarity. The negative arrow pointing to one side, one lead, that it means that this is the negative side of the capacitor, and this is the positive side of the capacitor. It has also two very important values, which is of course the capacitance, which is 22 microfarad here in this case, and also the rated voltage, which is 500 volts. It means kind of like the larger the voltage or the larger the capacitance, the larger the capacitor size would be. But this is a small capacitor, which is 22 microfarad, but it has a very large voltage rating, so it has to be a large capacitor. Unlike these, which has the opposite, which is a very large capacitance, which is 390,000, 3,900 microfarad, but only a very small voltage, which is 16 volts. And this is a radial form capacitor, which both leads are sticking out in one side, and you could see the negative side here, and the other side has no marking, which is positive. So the two important values are the capacitance and the rated voltage. If you unfortunately, if you put this in a circuit which has a higher voltage than its rated voltage, this will explode like a firecracker. So it's very dangerous. And as to my experience, it gives out some kind of smoke, which smells like popcorn. And this other large one is 450 volts, 220 microfarad, which is much larger. This is another one here, 300 volts, 220 microfarad. And this small one here, you got 470 microfarad with 35 volts rating. And you get the smaller one here also, which let's see what the rating here is. Yeah, it's 22 microfarad with 35 volts. Yeah. And I have a smaller one here, which is a higher voltage rating. This is 22 microfarad with 100 volts capacitance. This is 100 volts rating. This is one of the newer capacitors with newer materials, but still an electrolytic capacitor. It's small in size, but a higher voltage rating. So it has a better electrolytic dielectric, which can handle 100 volts. In the olden days, this would be, with the same rating, this would be a much larger capacitor. But with new materials nowadays, they're making it smaller and smaller and smaller. The main use of these electrolytic capacitors are for DC filtering in the power supply. So when you see these kinds of capacitors you will always see a negative and positive lead, so it's a polarized capacitor. So most likely it is for DC filtering in power supplies. And the next type of capacitor I'm going to show you, which I have, these are ceramic capacitors. It has a rating of 50 volts, and then there are smaller capacitors. They are in the PF range, 10 PF to 100 nanofarad. And if you open this, these are ceramic capacitors, the newer kinds of ceramic capacitors, and they're quite small, and they're rated 50 volts. So the capacitance is quite low capacitance. And the older type ceramic capacitor is a 100 PF picofarad, and that is the older type ceramic capacitor. These guys are the same type of dielectric. When you say ceramic or electrolytic or polyester, it means it's a type of dielectric the capacitor is using. Another type of capacitor is polyester capacitor, which is a brand called Sprague orange drop. This is also most of the capacitors like this, which does not have any polarity, which is non-polar capacitor, just like this. The smaller value, the smaller the value, the you won't see any polarity. Something less than 1 microfarad. Most likely will have no polarity, but if it is, then they will show you. And another type capacitor, which is the polyester capacitor. This has a rating of 630 volts and 400 volts, and this is what it looks like. These little green capacitors. These are low capacitance. You know, the highest I have here is 0.068 microfarad, and which is also a rating of 630 volts. And the lowest one I have is 0.001 microfarad. And you can see that it's small, and then it gets to be a larger one. And these capacitors, as I said, don't have any polarity. So when you look at the leads, let me see these leads here. There are no markings on the leads, and the leads have the same length, so they have no polarity at all. And the main use for these capacitors, the smaller capacitors, small value capacitors, which is non-polar capacitors, are for signal blocking. Signal pass-through and DC blocking, meaning it allows AC signal to go through it, and it blocks the DC voltage. These are the capacitors which I normally use for the tube amp, and I will show you again the tube amp, the back of the tube amp, so you will see the different capacitors. Now you have seen all the capacitors that I have, but we're going to concentrate on capacitors that we're going to use for the tube amplifier, so that we could easily understand that. See the tube amplifier that we were looking at a while ago in other lessons. You could see right away here, this big one here. This is an electrolytic capacitor. This is to filter out the AC and block the DC. And this is also a large electrolytic capacitor, and this is used for power supply filtering. So if when we look at the circuit diagram, you will see that. And there's only a few capacitors here, and there's another one here. This is also a 22 microfarad, I believe, capacitor, which is a 47 microfarad capacitor, which is have a rating of 50 volts. This is also a DC block and AC pass-through capacitor. And down there is a polyester capacitor, which is main purpose is to block DC and allow AC to go through from one circuit to the next. And that looks like it's a large capacitor. It is a low value but high voltage capacitor, and there's only a few capacitors used in this circuit, so that's one of the reasons why it sounds so good, because the less capacitors you have through that's using to pass signal through, the better the signal you can get. We'll talk about that later in our later videos. Is the switching DC to DC converter from 12 volts to 390 volts. You could see that there is also a tubular capacitor there, which is the electrolytic capacitor, 10 10 microfarad, 400 volts. It looks like there are two of them. This is for your DC filtering, and notice that the polarity also of it. Take a look at these here. This is the back of the DC to DC converter. You could see here, these are capacitors, really tiny surface mount capacitors. These are used for DC filtering and signal pass-through. Another one here. This is our DC to DC converter from 12 volts down to 6.3 volts. And you could see these are the tubular things. These are capacitors also. It has 220 microfarad at 35 volts. And with the newer technology nowadays, newer material technology, they could make it so small to make it a surface mount component. See, it's a surface mount component. It's just soldered on the surface of the printed board. There are two of that for the input and the output. You see the input there. It filters the DC, and the output, it also filters the DC to make sure that your DC is clean. And this is your DC to DC converter, adjustable DC to DC converter. Okay guys, thank you. This concludes our lesson for capacitors, and please like, comment, and subscribe. Till our next lesson, thank you very much. I'll see you next time. Have a nice day. Bye bye.